Hi, this is Phil Hilfiger coming to you from Paris, France. I would like to take a couple of minutes of your time to present to you a short presentation of advanced compressor functions. We'll be looking at peak and RMS readings, at the lookahead, sidechain, and also knee function within a compressor. For that, I have a simple drum beat here going on. I'll let you hear a little bit of that. Also, we have a bass line with like a synth bass sound, kind of a fat sound going on here. Let's have a listen to that bit. And to have the two together. So, one of the little problems that can arise in this kind of setup is that some of the frequencies will overlap whenever you have low frequency bass lines going on and notably bass drum kicks in there. You will see that there's overlapping frequencies. I can check into those. So basically what I'm seeing is that a lot of frequencies are in the same range right here in the upper 50 Hertz, 60 Hertz range. So in order to separate those frequencies a little better, I would usually use a compressor. However, if I just add a compressor to this large kind of synth sound, there's not much going to be happening. If I set my threshold here and I let this compressor interact, it basically is just going to work like a volume fader because the sound is so large that there's no real transient points that will create satisfactory compression. So this is where sidechaining comes in. Basically, the concept for sidechaining is that I will be using the sidechain function here, right here, and I will be feeding the audio signal from my drum track, and it is this audio signal that will steer the amount of compression that will be applied to the bass track. So whenever there's a high volume bass, for example a bass drum coming through, this is what will enable the compressor at that time. So let's see how that happens. I put my threshold in this area where normally the drum track should be interacting. I've got sidechain enabled. I've chosen my drum track as the audio signal that will determine the interaction with the compressor, and I can even choose if I want to use post, pre, or post mixer, pre-post effects or post mixer settings for that. So let's try that out. And here we see that actually the compressor is acting like we would want it to. There's movement going on, and it's taken into account the decibels that are coming from the audio track, or the MIDI track in this case, but from my drum track. There's lots of experimenting that you can do with that. You can vary the threshold, obviously. You can vary the ratio. And another option that's indicated here is the knee. And the knee basically indicates over a decibel range, either at 0 decibel, the compressor will hit at this point and start applying linearly compression, or it will be fading in gradually over this line, and you see the knee, the kind of bend that will be smoothened out. Look ahead is another option in here. Whenever you add compression, there's always a small delay, because once the threshold is reached, the software will still need to calculate and apply the compression, so some transients might get lost. And one way of dealing with this is the lookahead function, which basically will delay just by a tiny amount, 1 millisecond, 10 milliseconds. You have the options here, the input signal, and and that way the compression is already active when that input signal comes in, just slightly delayed. So that's another way of dealing with that. We've got envelope settings here for peak, RMS, which means root mean square, and which is a average calculation of the sound level, which is close to how a human being experiences the sound level. And you even have a third option, which is called Opto here. Basically, it gives a nonlinear release to the compressor. It will decompress, if you will, rapidly, and then smooth out the decompression curve as you get closer to the original signal. So experiment with this, experiment with the settings to kind of get the sound you're looking for. Thanks for your time. Have a good day. Bye.